Good afternoon. Welcome to today's webinar. We are excited to present to you Unearthing Opportunities, Advances in Networked Geothermal Systems to Meet Today's Customer Heating Needs. I'm Danielle Sass-Burnett with NARUC, the National Association of Regulatory Utility Commissioners. And as you can see, we have a great lineup of speakers who are looking forward to sharing their knowledge and experience on this topic today. As you heard, today's webinar is being recorded and we will post the slides and the recording on NARUC's website. NARUC is the National Association of Regulatory Utility Commissioners. We are the nonprofit organization that supports state public utility commissions across the country. Our members are in all 50 states, DC, Puerto Rico, and the Virgin Islands. And I am the Senior Director for the Center for Partnerships and Innovation, which is focused on providing technical assistance through relationship building, resource development, training to assist utility commissioners and commission staff in their very complex jobs. NARUC CPI provides lots of resources, publications, and webinars, and you can find out more about those on our website and throughout the NARUC website. I just wanted to flag that this is but one of many events that NARUC and CPI have been hosting and will be hosting in the near future. You can look to our events page to find out more and register for a few virtual events, including on virtual power plants, workforce development, AI and energy demands, and wildfires throughout the next month and a half. And there are some in-person events coming up as well in September and October. You can get registered for those. And if you are a NARUC member, you can typically get a travel stipend. So there is no cost to your commission in order to attend any of our in-person events. For today's webinar, we are, as I said, excited to talk about networked geothermal systems. And our moderator today is Commissioner Megan Gilman from the Colorado Public Utilities Commission. She has been a commissioner for a few years and has a background as an engineer and also worked with many building energy trades and owning her own business as a contractor. Commissioner Gilman, would you like to introduce our speakers for today?
Hi, good afternoon. I think everyone's in the afternoon now, which is excellent. Wonderful to see you all, and pleased you're all joining us today for what I expect to be a really great, informative hour of discussion. As Danielle pointed out, my name is Megan Gilman. I'm a commissioner on the Colorado Public Utilities Commission. Generally, my voice is a little louder. Apologies. Still battling off something today. But today we have some really great experts ready to share their time and knowledge on a topic that potentially may be new to some of you, but really, as I think you'll hear, generally relies upon a lot of time-tested technology, drilling techniques, and mechanical equipment to deliver the same comfort experience to end users, utilizing a highly efficient electrified solution. And just by way of background, we here in Colorado are working hard, as in many states, to deliver on an energy transition to avoid the worst impacts of climate change and do so in a way that's affordable, reliable, and equitable to share the benefits of that transition with our neighbors. But in doing so, there are a lot of tough questions and details that we're going to have to get right. So I think it's important, especially for commissioners and stakeholders, to understand the full range of technology options that are available to us as we move forward. And as we talk about those, I find network geothermal to be a particularly interesting solution, especially given some of the potential infrastructure impacts that we see associated with electrification, any backup of different sources. And I think the panelists will get into that pretty well today. And I was able to see an operating system here in Colorado, an operating network geothermal system here in Colorado a few years ago. And it blew my mind in all the best ways, I have to say. My first job out of college, I was working as a mechanical engineer on building systems. And it was really interesting for me to be able to see that system working and essentially sharing heat from one place to another instead of creating heating and cooling simultaneously from scratch. So very interested to hear a lot of the details our panelists have to share with us today. So without further ado, I'll introduce our first panelist. who is Dr. Alexis McKittrick, a program manager with the U.S. Department of Energy's Geothermal Technologies Office. She oversees both low temperature and ambient co-produced resources and hydrothermal resources in her research portfolio. So welcome, Alexis. Thank you for joining us.
Thanks so much for the kind introduction. Can I just do a really quick, can you hear me okay?
Sounds great to me.
Fantastic.
Thanks.
Wonderful. And team from Nehru, are you all going to be sharing my slides or do I need to bring those up?
We'll have them momentarily.
Fantastic. Thank you guys so much. As those are coming up, I'll just share, as was mentioned, I'm here from the Geothermal Technologies Office within the U.S. Department of Energy. Very excited to kick off today's webinar to provide a bit of an overview of kind of how DOE is thinking about networked geothermal heating and cooling, and also, honestly, how this space is growing in leaps and bounds very quickly. And excited for you to not only hear from me, but from everyone in the panel as we go forward in time. I think this is going to be a really important space for utility engagement as we move forward. So you can go ahead and go on to the next slide. Thanks so much. So again, I'm kind of tasked today with giving a bit of an overview of the geothermal district heating and cooling space. As you may hear from others, this space does have a number of different kind of names. Some folks use thermal energy networks for both geothermal as well as other stranded heat resources, such as wastewater or sewers and other places where waste heat could be better utilized in a heating and cooling system. Geothermal district heating and cooling is what DOE typically uses, but again, recognize that this is a much broader space. So what you see in front of you is essentially kind of a rough schematic of these systems. They essentially are taking the geothermal heat pump or GHP concept, where you have a heat pump at a building and you are using piping to go to depths that you're hitting that nice temperature in the Earth's subsurface where it's essentially the same year round. What this allows is that when you have, say, 65 or 70 degree temperature that where you're exchanging thermal energy with the ground, you can provide heating by exchanging that temperature in the winter, and then of course provide cooling in the summer. And that depth, if folks are wondering, I'm kind of pointing towards the energy station end of this graphic, is usually about 500 feet, kind of give or take in the specific geology. And all the way over on the left, again, that energy station is representing not only that heat exchange with the ground in the case of these district systems, but it's also representing what we call your borehole field. And there's two on this graphic. Typically, for a larger district system or community system or university system, there could be hundreds, and there could be more than one of them, depending upon the size and the heating and cooling needs of your system. And then, of course, you have the networked part of your underground loop, which is shown kind of in the horizontal as you go across this graphic. And that's going to be a loop that is taking that warmed or cooled fluid and making sure that it has connectivity to all of the different buildings that are part of the network. And then, of course, as I mentioned a minute ago, at the individual buildings, you're also going to have a geothermal heat pump or at each building that's appropriately sized, right, for that building and its intake. Interestingly enough, we saw these systems emerge first on university campuses, and I would say grow really on university campuses in the US. I think I have at least one example of a university system as we go through, but there's a number. They come in a lot of different shapes and sizes. So one reason why we struggle with having one graphic that provides an overview of these systems is that they really can come in a lot of different shapes and sizes. There are some that are a couple of large buildings that work together. There are some that are, full communities that are largely residential that are networked together. Universities, as you all can imagine, right, are a lot of mixed use systems, everything from kind of dormitories to labs and lecture halls. And so there really is a lot of breadth in what these systems can provide. Obviously, almost fully decarbed heating and cooling is a big piece of that. And then water heating and cooling can be part of these systems as well. One other thing I'd want to note before I move on to the next slide is just that we are actually seeing a lot of these systems that are starting to hybridize with other types of renewables. So in particular, as geothermal heat pumps do use electricities, they are kind of an electrified technology, albeit they don't use a lot of electricity, but these systems are often hybridized with solar PV, solar being used for your lights, and the electricity, anything else that runs off electricity, the heat pump that runs off electricity, and then the geothermal systems for, again, decarbed heating and cooling. This is a big hit again on university campuses, especially those that have large decarbonization or climate goals. And again, we're seeing that grow as well in cities and localities, as well as the number of climate plans across the nation increase. And the last point on this one is just that, and this part of what brings me in front of you all today, is that we have seen a shift, not just from kind of a university scale system or community scale system. Folks are now starting to talk about utility scale geothermal, and these concepts have been proven in enough different spaces and places in the US that folks recognize that they can work on larger scales as well. And so could geothermal replace natural gas in some places, replace home heating oil, replace other heating and cooling as we look to the country's broader decarbonization goals? Next slide, please. And on this slide, I have a graphic of the Carleton College system in Minnesota. Of course, if you're not familiar with Carleton, what I really like about this is it has actually both vertical and horizontal boreholes. So if you kind of see the dotted rectangles there, those are the vertical borehole fields, and then a horizontal borehole field kind of off to the right there. Also, the previous graphic that I showed was kind of one loop that provided both heating and cooling. This system is what's called a 4G system, where essentially you have separate loops that are the networked loops for both heating and cooling. So basically like a hot loop and a cold loop. And so that is also, again, just another configuration of the way that these can be made to work for whatever your situation is. I also just wanted to mention quickly that there are a number of systems in the US that use a technology like this for heating only. It's called direct use geothermal. It's usually less geothermal heat pump based and more about kind of bringing, drilling a bit deeper and bringing really hot fluid to the surface and kind of using heat exchange for heating. Those systems have been around for a long time. One of the best examples and most commonly referenced is the 90 building system in Boise, Idaho. So if you are interested in that heating only application, do feel free to reach out to me or to look up that Boise system, but I am going to concentrate on kind of the heating and cooling space today. Next slide, please. And then we would like to think at the Department of Energy that we are kind of helping move this space forward. And one of the big ways that we're doing that is with our community geothermal portfolio. We had the opportunity to run a funding opportunity several years ago that kind of served several different purposes. We saw this emergence of these community scale, district scale geothermal systems that were networked in universities. We hadn't seen as many of them move into communities, and we wanted to show through a set of innovative projects that these could work in a lot of different places in the US. So that they could work in urban and suburban environments and rural and remote environments, that they could work in different geologies and geographies across the US. And that they could be used to reduce energy burden, that they could be used to reduce environmental burden for communities, and really not only create a decarbonization solution for community scale heating and cooling, but also help remove burden from communities that have historically, unfortunately, disproportionately received that burden. So we are very proud of this set of projects. Again, it's 11 different communities across 10 states, and you can see from the pens in the map kind of where those fall. and they're listed here on the right. I think what I would say is, these systems and the amazing teams that go with them. I'm sorry, I don't have time to go into all different 11 projects. But these teams have all been working very hard to design their community scale systems for the last year. And we're actually about to go through essentially a down select process. We're going to move from the design phase to the implementation phase and look for at least several of these communities actually install their systems on the ground. And so that's when we're really going to get to see some really exciting new systems that hopefully will serve as great models for everyone that's looking at networked geothermal. Next slide, please. And then I wanted to make sure to spend a couple minutes talking about some of the analytical resources that we have for folks. One really important analysis that came out last December is our geothermal heat pump impacts analysis, or GHP impacts analysis. This was run out of our data modeling and analysis team at DOE's GTO, and was conducted by Oak Ridge National Lab and the National Renewable Energy Laboratory, or NREL. And essentially it looked at what if we were able to move forward with mass deployment of geothermal heat pumps at buildings? What would happen? What would the emissions reduction be? What would the impact on the grid be? What would be the effects on building electricity use? And how would the bulk power system react if we suddenly went from the volume of geothermal heat pumps that we have now kind of to almost 70% of the building stock having geothermal heat pumps installed? One really important note, since we are talking about networked geothermal here, is that while we do plan on a moving forward analysis in the thermal energy networks and network geothermal space, this particular analysis is just focused on individual building GHPs. So think about, again, commercial buildings, residential buildings. If 70% of them were converted to GHPs over time, what would that look like? And we found, next slide, please, some really exciting results. One was the absolutely phenomenal impact that converting to geothermal heat pump based heating and cooling would have on the electric grid, right? Everybody was expecting large GHG emission reductions, right? We have that on the bottom. 7 gigatons of carbon equivalent could be removed from US emissions. That's gigantic and phenomenal. But it wasn't necessarily surprising, right? Because we know this is a big shift away from fossil fuel-based heating and cooling sources. What surprised us was this grid impact in the top 2 bullets. So eliminating the need for over 43,000 miles of new transmission infrastructure. And for those familiar with the Sandia transmission project, which I imagine a lot of folks on this call are, it's equivalent to 44 Sandia transition projects that essentially would not be needed in the future simply because we are lowering that total demand on the grid and we are lowering the peak requirements for the grid with this technology. And then also would reduce over 400 gigawatts of nationwide generation capacity that would be needed. So again, as we are thinking about electrifying America and thinking about how we can build out the grid to better support that, employing this technology and employing GHPs would actually reduce the total amount that we would need to build out for that grid. So again, really exciting results there. And that's not all. Scoot over to the next slide. A little bit more on this. So we did look specifically at different climate zones across the US. And in particular, I think this is broken out by balancing area authorities, I believe. We might be seeing counties on this one, apologies. But essentially what this is showing us is that we're electrifying heating. So again, GHPs use electricity, right? So we're kind of electrified heating of all these climate zones. Not only do you get those really high efficiencies that I talked about, you're reducing the annual electric consumption in almost every balancing area authority in the US. And that is gigantic. That electricity savings, again, that reduction of the amount that you need, kind of those things coupled together really do make a giant difference on the US electrical grid and for individual consumers. So it's kind of an everyone wins scenario. And then we looked at a few different scenarios, which I didn't jump into too much here, but again, saw really strong reductions in natural generation requirements based on the different scenarios that we looked at, both the decarb and electrification future scenario. And again, if you kind of jump onto the links here that are provided, and I can see if we can provide those in the chat afterwards if needed. Definitely would love for folks to dive into this and dive into the different scenarios that we looked at. And I think one of the most powerful messages right here at the bottom is just that the cost of grid power and that environmental benefit, obviously we focus on the folks that are using GHPs, but it actually brings those things down even for the folks who aren't electing to use them or aren't having them in this scenario. So again, when I say win for all, I really mean a win for all, even those that might not have installed these systems. So that's the future, right? That is the what could we do if we made better use of this technologies. And I think I would say that these networked geothermal systems are just the next step. And that like this GHP technology, this is something we have today, right? This is something that is installed in US homes now, is commercial and available. And thermal energy networks and network geothermal is the next evolution where we're taking these types of systems and we are networking them together for better and more beneficial use across consumers. Next slide, please. And then I also wanted to mention one really important one piece of work that we are undertaking right now at the Department of Energy. Folks may or may not have heard about our series of pathways to commercial liftoff reports. We are doing one. Our next one, in fact, will be for geothermal heating and cooling space. So again, this is part of a whole family of reports, and the link on the bottom will take you to the commercial liftoff kind of homepage. We have one on geothermal power if you're interested in that side, and next gen geothermal power, as well as a number of other technology spaces. The liftoff reports are intended to develop kind of a common fact base between government and the private sector on promising technologies, on emerging technologies, just like the geothermal heating and cooling and thermal network space. Again, as we look at geothermal heat pumps and thermal energy networks, those are going to be the focus for this report. And we say late 2024 in our publication here, but really we're targeting the NARUC National Conference to hopefully be able to announce this liftoff report. So I wanted to give you all a little teaser that would be coming. And if we go to
sorry to interrupt you.
No
We're just
worries.
trying to stay on schedule, so as quick as you can with the last slide.
Sure. I will go ahead and wrap up.
So sorry to interrupt.
No worries at all. This is just more of a reference slide for folks. Again, geothermal heat pumps have kind of some first of a kind, excuse me, tax credits right now. We just encourage you all to check out the amazing fact sheets that we have on our website if it's informational too, especially the commercial GHP credits. And then also wanted to call attention to the fact that we have a number of states that are developing legislation in this network geothermal space or thermal energy network space, and building decarbonization coalition has probably the best summary of that. But this is part of why we are hearing and seeing so much interest in network geothermal. It's a lot of folks that are focused on decarbonization, and then some folks whose states are looking at this saying, hey, we want to see some geothermal pilots and we want to understand what that looks like. So again, just a couple of resources for folks. You want to flip over to put up the QR code just to make sure our comms team gets some credit if folks want to scan that quickly for all of the great work and references and resources that they have on our website. I encourage everyone to check those out. Thanks so much for the opportunity to present.
Thanks, Dr. McKittrick. I very much appreciate it. And I'll just note Danielle has been popping a lot of these live links right in the chat for everybody. And just to keep us on track, we promised y'all just an hour. I will flip us to our next presenter. Thank you so much. Our next presenter is Zainab Magavi, who's the Executive Director of HEET. And in addition to doing some methane leakage work initially, now she has really been a pioneer and a strong voice in looking at network geothermal as potential solutions to decarbonizing heating. So Zainab, happy to turn it over to you.
I'm delighted to be here to share more information about this really exciting space. It is always a pleasure. We joke frequently that we are networking people at the same time that we're networking buildings. I want to comment that HEET is a nonprofit that attempts to maintain its independence in change leadership in the space and accepts no money from the industries like gas, geo, et cetera. And we really have a vision of delivering decarbonization through this infrastructure. Next slide. Alexis gave us a great commentary on some of the language and the, I almost want to say menagerie of different options for how to connect a geothermal heat pump and a district system or utility scale system. I use this slide to comment that, you know, here are 3 amazing articles, press pieces from prominent groups, and they each use a different terminology for this exact same technology. So does that matter? A rose by any other name smells the same. And I would say from a regulatory standpoint, what matters is what it actually is. So next slide. Very briefly, I'm going to spend a couple minutes on that. I like to say that the word geothermal is very much like the last name of a family of technologies. And the thing they all have in common is they provide stable, non-intermittent energy. Yay. But we're going to set aside electricity. Oh, I see my slide got a little squished. The district heat that Alexis mentioned, where like in Idaho, and also we're setting aside those individual buildings, which are awesome. But what we're talking about is this utility scale infrastructure that's delivering both heating and cooling. And for now, I'm going to just keep calling it a geothermal network. But the critical part is it's that shallow 500 feet, and therefore it's anywhere and everywhere. So you don't need a specific location with some kind of hot spring. This is deployable all over the country, as the maps from Alexis showed. Next slide. And I apologize for so much language, but I really wanted to give you a sense, because whichever state you're in, you probably have more than one name for this. And the best way to tackle understanding what the proposal or infrastructure is that you're talking about is to divide it into 3 parts. And this also is critical to understanding costs and rational costs going forward. So first, we have the buildings. And in the buildings, we have the ground source heat pump, the geothermal heat pump. That's the same thing. And it's a technology that's been around for 50 years. A lot of what we have here, all the components, are old tech. Then we have the infrastructure or distribution infrastructure that connects the buildings together. And that is, again, old tech. We're talking pipes and pumps. This is even the same pipes as we currently put in the ground in our gas network. And that's sometimes referred to as an ambient temperature loop, thermal highway. I mean, there are a lot of names out there. I'm just warning you. But it's maybe most commonly at the moment referred to as a thermal energy network. And the last part, really critical, is that thermal resources category. And this is really thinking of it as our sources, our sinks, and our storage all at once, which is where it gets a little interesting and a little complex. And that's part of why it's delivering such crazy impacts, as Alexis described. So those thermal resources, the baseload technology that we've been discussing is the geothermal borehole, sometimes called GeoExchange. But we can also, kind of like plug and play Lego, add onto that thermal network wastewater thermal, industrial waste heat, I think data centers, other interesting buildings like ice hockey rinks, thermal energy storage, solar thermal, the lakes and the ocean that are overheating. There is a lot of fabulous thermal resources all around us. And once we've built that thermal network, the infrastructure part, the middle piece here, we can deliver and move that thermal energy to our buildings. So the list on the right is overwhelming. It's all of the currently in use terms across the country, including, you'll see 5G HCD. That is a classic terminology from Europe for 5th generation heating and cooling district. Again, every one of these is almost the same thing. Don't worry. Next slide. So what matters is what you're getting from the infrastructure. And I'm distracted by my slides, so all the text got a little wonky somehow. Apologies. So these are actually the requirements that HEET set out to meet in 2016, 2017. And a lot of people thought they were a little out there, ridiculous. How could one technology meet all of these? And so I'm going to briefly go over the benefits of geothermal networks and how we have a shot at all of these listed. So first of all, high safety and security. Look, I've worked a lot with the gas system. Safety matters. And this infrastructure is incredibly safe. It is not explosive. And furthermore, there's a security and an energy security to having local energy and to having it all underground. That leads also to a reliability and resilience. There are some amazing cases. One of the only neighborhoods in a portion of Texas that did not go down in Superstorm Uri was the geothermal network in Whisper Valley. The only electric company in Oklahoma that did not have to bill their customers after Superstorm Uri was the electric co-op who had 2,000 geothermal heat pumps. There's a lot of cases of how reliable and resilient this infrastructure can be. Of course, affordability, we're going to come to that. Zero emissions, we've got that. As long as we get our electric supply to zero, this will be zero, but in most states, immediately, as Alexa said, this immediately reduces emissions. And there's the workforce component. And that is a beautiful part of this story because we have an existing workforce that knows how to deal with this pipe in our gas utilities, and they are excited to go geo as well. Pipe fitters have come out nationally in support and have been part of driving the change. Equity, we're going to come to that next. Scalable and adaptable. This is dependent on the design. The single pipe design has a lot of flexibility for scalability and adaptability, and that's something to consider when you are deciding or approving a design. Finally, it does have to make economic sense, not just for the utility, but for everyone involved. And we kind of need speed and scale. Next slide. And I probably need to speed up. So very quickly, just to kind of give you some touch points, the geothermal heat pump is the lowest cost of energy today. Like that is not something we're saying is going to happen in the future. It is. And similarly, the cost of energy monthly and the O&M costs are the lowest for network geothermal. The cost question that we have to tackle as we consider scaling this technology is the question of paying and amortizing the upfront infrastructure cost of the boreholes and the network. And we're attempting to approach that in the standard way, similar to a gas utility. Next slide. And there really is a critical piece to this when we think about areas that do have gas infrastructure that also have climate mandates, a building by building transition off of gas infrastructure. We know the story. It could really end up creating a high burden on remaining customers. And this is just a lovely graph from a study in Massachusetts, really showing that if we create a merged ratepayer base, we can stabilize that transition, not just keeping costs low for all customers, but also I would add, keeping and maintaining a workforce to ensure safety on the gas system. Next slide. Just to kind of aim again, this is a study by HEET, a feasibility study for Massachusetts, where we looked at different types of street segments. And this is an everywhere technology for anything above a low density residential. Rural miles between houses doesn't make sense. But it really has some cost advantages in a high density mixed use setting, which is typically one of the hardest areas to decarbonize. And that's pretty exciting. Next. And this is one of my favorite slides. It really it's just a different way to look at the same amazing results that Alexis shared, that there is a really strong connection between the choice of building decarbonization technology and the impact on the electric grid. You probably all know about the duck curve. Well, now you're in the inn and you know about the falcon curve. It's scarier than the duck. And this is a seasonal, January to January, all building electric use for different efficiency technologies. And when we lower that efficiency, we get all those wonderful benefits that Alexis talked about. And it's critical that we somehow connect these cost impacts to get the least cost path forward, which of course means we're going to have to think about how to monetize the benefit of geothermal on the electric grid. Next slide. And I just want to cover that wonderful case study that Commissioner Gilman mentioned in Colorado. It's been in the ground for, I think, over 15 years. We like to call it a living lab. These are some photos from there. They had about a 10-year payback in the beginning and a $1 million a year energy savings, huge carbon reduction, covering 100% of their heat. But they also had some outcomes that were unexpectedly beautiful. They cut their water use by 60%, and they're on the Colorado River. And they did that by moving cooling off of evaporative chillers. So if you're in a state that really is struggling with water, this is something to pay attention to. And then we also got our first efficiency numbers out of this project. That's a 570% system efficiency annual, with a winter peak efficiency of 890%. And just to give you a sense, your gas boiler is sometimes approaching, a really good one, 97, 98%. So if you think about the difference, that is not just energy, it's cost, it's a lot of things. So that's pretty exciting. Next slide. So this is just the benefits list checked off. We have a really good shot at everything plus, and that, I think, next slide, is why we're having unusual partnerships come together. And this is just an example in Massachusetts, where I'm from, of the unusual partnership between climate advocates and gas utility. You're going to hear from me and then from Eric. We're working together closely, Eversource and HEET. And I think that's not a one-off. It's happening across the country. Next slide. And I want to give you a sense of that. HEET's working on networking people together, I mentioned. And this is part of the outcome, not just of that crazy set of benefits and the education and the excitement. More than 6 states have permissioned gas utilities to sell thermal energy using this technology. And some of them have even addressed, for example, in Washington state, evolving the obligation to serve to include this technology. In Maryland, the Warmth Act directs them to contribute data to a universal database. There's great stuff happening. It's very exciting. Next slide. And there's an advocacy coalition that is similar states working to educate and support rational legislation and regulation. And next slide. And even more exciting is that there's just a rapidly growing list of gas utilities who are meeting regularly in the Utility Network Geothermal Coalition to consider and evaluate this potential path forward. And that is amazing, because that is a testament to the potential scaling of this technology. Next slide. And finally, I will add that HEET has assembled a national research team that we're just incredibly privileged to convene, including a bunch of great leaders. And we are providing an open database that will be published this fall of this specific project. I think that's so important because we need clear data in order to make rational decisions and policies from these utility scale projects. And we also have an open library of resources and are doing a whole bunch of studies on impacts and scaling. Next slide. And
we just need to wrap up.
Absolutely. We're done. Get next slide. Apologies. Yes, so I will just say that it's been a privilege to come together, and we are convening some regulators in early October to share information, hopefully in a shorter way. And feel free to reach out to info@heet.org to join us.
Thank you so much. Thank you very, very much for your presentation today, all the work you've done to advance in this area. Really appreciate it. And a good transition there at the end, talking about utilities that are undertaking some of this work. And so I will introduce Eric. I do just want to mention, feel free to put questions in the chat. We're trying to reserve some time at the end for question and answer, but it will be relatively short. So go ahead, don't be shy, put some questions in there, and folks are already answering them as we go. So I'm pleased to introduce Eric Bosworth. He is the manager of Clean Technology Business Unit at Eversource Gas and has actually worked on implementing some of the very types of projects we're talking about. So welcome, Eric.
Thank you, Commissioner Gilman, and everybody for joining us today. Next slide, please. Just very briefly, Eversource Energy, we're a mixed utility in the Northeast, approximately 4.4 million energy customers across gas, electric, and water. And specifically in this case, we're talking about our geothermal pilot that falls underneath the gas business in Massachusetts. Next slide, please. So really hoping to kind of bring the utility perspective here and also some examples of an actual project that is, as of today, in the ground. A little bit of background on it. Back in 2020, in a gas rate case, we proposed demonstrating this concept of a networked geothermal system in a neighborhood in Framingham, Massachusetts. We initially proposed about a 300-ton, maximum capacity system, and we set out a number of feasibility and site selection criteria that we were going to meet. And the idea was really to answer questions around, is this a technology that works from a technological perspective and an economic one, and is the gas utility a good candidate for deploying these, especially when we all understand that scale is needed here to have a real impact. So that was approved back in 2020, and we began going into design site selection work. And then as of today, we have been under construction for about the last 14 months or so, and we're taking our first customers on the system now. Next slide, please. This slide shows you an overview of what that system actually looks like. So it is approximately 1 mile of 8-inch HDPE main running in a single pipe loop through a neighborhood in Framingham, Massachusetts. We've got about 140 individual customers on, and that's really a great cross-section of all different types of our typical utility customers. We have single-family homes. We've got low-income Framingham Housing Authority apartments. We have some larger commercial with parts of a Framingham public school building. We've got a fire station, a cabinet shop, some small local businesses, a Gulf gas station, for example. And what it really does is it provides us with a lot of great insights into what that transition looks like for different types of customers, whether they're coming from gas service, oil service, electric resistance service in some cases, and how a networked geothermal system will perform for them, and what the increase in efficiency will look like and reduction in emissions could be for each of these different customer types. Next slide, please. So why is this project being undertaken by a gas utility if, ultimately at the end of the day, it is electrification? And really, there were a number of reasons that we felt that this fit pretty snugly within the typical gas utility business. Network geothermal systems are inherently capital intensive. There's costs up front to do the drilling, put the pipes in the street. The maintenance and operations of the system is very similar to a water, gas, or electric utility type system. They're long-lived assets. These boreholes will last potentially 50, 60, 100 years in the ground. And, it very well fits into that regulated utility service style model. Finally, from a customer perspective, it's also providing energy to the community, and the customers really want someone like the utility that they trust to be delivering heating and cooling 24/7, 365, and they know we're going to be there if there are ever any issues on the system. Next slide, please. Kind of looking more at those gaswork similarities, though, the installation of these systems is very, very similar to traditional gaswork as well. This picture here shows you a fusion setup for geothermal pipe that was actually put in Framingham. And if you didn't know that was geothermal pipe, anybody familiar with gas or water utility installation could mistake it for that. It's the exact same resins that we use with gas pipe installations, exact same fusion techniques. We're in the street trenching, installing these pipes. We're even using similar systems like our GIS, our markout systems, looking at something like a SCADA to control and monitor it. All of it fits very, very familiarly into what we would typically do day to day in the gas business. Next slide, please. So looking at each of the kind of components of a networked geothermal system here, you have your main and service installation. As I said, this is kind of utility bread and butter. This is what we do every day. These are some pictures of the geothermal pipe that we did put in Framingham, as well as a service that was pulled to one of the customers on the loop. All of this work was completed as of last November. The entire distribution loop was in. And honestly, that was the part of the project that was the most familiar to us. It went very smoothly, on time, and pretty much as expected. Last point here, we did bury it a little bit deeper than traditional gas service. We were at about 5 feet underneath the roadway, but otherwise almost identical to a gas pipe installation project. Next slide, please. Second component of these systems are the boreholes themselves that we're using for the energy storage, pulling heat out in the winter, putting it in the summer. In the case of our loop, we had 3 separate bore fields on the system across approximately 90 boreholes total to provide energy to those 140 customers. The one thing I'll note on this slide is, the picture on the left there is a little bit different from the other two. We did drill one of our bore fields deviated, which means we put boreholes out at an angle to get a bunch more underground, thermal conductivity and space from a very small surface footprint. The second and third bore fields were drilled traditionally, which means a vertical hole, move 20 or 25 feet, put another vertical hole down, and string them together in rows. Next slide, please. Building conversions, kind of the last step to all of it. These are some photos here of 2 of the conversions that we did. One is a low-income housing authority apartment that uses console units, and the other are rooftop units that were placed on top of a Framingham public school building. The point I wanted to make here is just that the technology is very versatile, and we really didn't run into any scenarios where we couldn't convert a building. We had a way to get these into single-family homes, apartments, large commercial buildings. It's just a matter of finding the specific piece of technology that fits that application. Next slide, please. Finally, operations and monitor. As I said, our loop in Framingham is in and running at this point, and so we're going to go into 2 years here, 2 heating and cooling seasons of operations and data gathering. The point being to really look at how the system performs and run a lot of those numbers on what the economics look like, what the carbon savings are, what the energy savings are, and ultimately figure out what a business model can look like going forward. Next slide, please. Last point I wanted to make here was on stakeholder engagement. I'd be remiss if I forgot to mention all of the hard work that we did really getting out into the community. And this is another area where specifically, using our utility sales folks to go out and effectively sell geothermal was a huge positive point of this project. Getting out and holding things like office hours for the local residents to stop by and ask questions, developing fact pages, one pagers that we can deliver out to the community so that they really understand the technology and the project was hugely beneficial here. And I can't stress enough how much that cooperation between the utility, the community, outside stakeholders has a great impact on the deployment of projects like this. Next slide, please. Talking about that value proposition, this is just kind of a quick breakdown across the different subsets that are affected by something like a network geothermal deployment. You've got the customer benefits, things like low utility costs to operate the systems, getting both heating and cooling, and very low maintenance requirements. There's obviously utility benefits with how it fits with a traditional utility business model. And then there's also state benefits moving towards things like meeting decarbonization goals, reducing energy usage, et cetera. And so there really is a wide cross-section of groups that benefit from implementing projects like this. Next slide, please. Finally, just wanted to leave folks with what success looks like in the case of this pilot and really the questions that we're trying to answer by implementing it. Obviously, there's the technical ones around performance and energy usage and cost, but I also wanted to highlight there's a customer acceptance, question that we're trying to prove out here as well on how they like the systems, how comfortable they are, if they'd be willing to recommend it to their family, to their friends, to their neighbors. And so we want to get a really holistic approach of all of the benefits to a system like this, not just the numbers around, what the costs and the energy usage are. So I will leave it at that. If you want to hop to the next slide, I think it's just a Q&A, and hopefully there are some questions that we can field for you.
Thank you so much. I really appreciate you sharing with us as well. If I can have the other panelists tick on as well, we'll do a somewhat brief Q&A. You all have been doing a great job answering on the fly as we go within the Q&A. So I'd offer our participants to take a look at all of the great answers, questions and answers that have been posed already. Dr. McKittrick, I want to start with you, and these will be somewhat rapid fire since we're zeroing in on the end of the hour. So you pointed out the potential savings on the electric system, the electric infrastructure, were kind of some of the most eye-popping results to you as you looked. Almost 44,000 miles of new transmission, 410 gigawatts of generation. And those are pretty shocking values. And I wonder, just to kind of put a finer point for our audience on what is causing that, you think electrify, heat, you need more, not less. And so is that really just the gains we're getting in the cooling efficiency, through the efficiency being that the majority of the country still peaks on cooling load?
Yeah, I would I definitely understand that viewpoint. I would say that I would make it a little bit more broader and say it's overall like the efficiency of these systems, the very high coefficients of performance that they get, especially in buildings that have been retrofitted, to think about their building envelope and other efficiency measures that can be put into place. So yes, overall efficiency, I would say, for heating and for cooling. And the only reason why I don't want to concentrate on cooling is because we do get a lot of questions about whether or not these systems can work in really cold climates. And the short answer is yes, they can. Absolutely, they can. And you also have the Carleton College example in Minnesota is just one to highlight. Also, these systems, because of the way that they operate, they actually can lower the peak demand on the grid, kind of coupled with that efficiencies. And so that's also helping, obviously, kind of level out that load. When you think about network systems, which weren't part of the impact study, right? But those absolutely can you can utilize kind of mixed use across the network that then will kind of even out that load distribution across the day, across the seasons for different buildings. Sorry, you asked for a quick answer. That wasn't quick, but I could talk about this all day.
Excellent. No, I appreciate it. And Eric, as I understand, you're working a lot to kind of understand surveying customers and the comfort, the experience, the customer acceptance. So probably from you and Zainab, what are we hearing? This is part of the debate with electrification, with decarbonizing heating. Do customers care necessarily that what made their heat was a molecule or an electron, or did it come from inside the earth? What are we hearing? Are the comfort outcomes relatively the same? Just curious what data we've heard so far.
So happy to tackle that one first. I will say it's definitely a customer by customer question. Some customers don't even really know where their heat is coming from now. And so part of it is education. One thing I will point out with network geothermal, though, is there's a huge benefit that we actually didn't anticipate going into this for providing that cooling in addition to the heating service. When you come into somebody's home and tell them, hey, I'm going to replace your heating with geothermal, they kind of say, yeah, okay, that sounds great. And then you say you're getting central air conditioning as well, and their eyes light up. And so I think it's important to really understand the full picture of benefits that customers are receiving and communicate that clearly. And that has been something at least that we learned along the way.
Yeah, I would just add that, one of the next projects that's happening in a kind of Boston Housing Authority, we heard a lot from the residents about the excitement of air quality improvements. So that was on the radar for some folks, and but the cooling is huge. The cooling is definitely high up there.
Thank you, appreciate it. All right, lightning round, 30 seconds, 45 seconds. What are you seeing in either the utility, regulatory, or legislative space across the US that's kind of giving you the most excitement as we go forward? Should people look, I know we have some great examples here, you can cheat and point to one of those, but like, what are you seeing in the innovation in this landscape that you want to point people to? Go ahead, jump off. I hit you with all with it.
Everything about the space is super exciting. So it's like impossible to name one thing, but I'm gonna say one thing that's just awesomely fun. And that is that the ocean and rivers and lakes, they've absorbed, so like ocean has absorbed 600 times the thermal energy that all of humanity uses yearly. And we can pull it out. We have the technology, we have heat pumps, we can redistribute it through thermal networks. That's kind of amazing.
Yeah, I'm gonna jump in and say a little bit of a traitor to the federal government here, but states are making me really excited about this. Not just the legislation that's being passed in different spaces and places in the US that's focused on some of these geothermal network pilots, but also state incentives, state grant funding for these types of systems. I mentioned the federal tax credits and the 30% for residential GHP systems and the commercial ITC as well, but states are adding on to that, right? They're saying, yes, you get those tax credits, and here's another 10 or 20% of the tax credit from the state, or we're interested in putting out grant funding. And New York and Colorado are really leading the way in that space. Not to in any way discredit Massachusetts on the call here, but I know those are two states that are just really pumping out a lot of funding in geothermal networks. And I think we're going to see other states follow suit here in the near future.
Eric?
Quickly, just finally for me, maybe no surprise, but other utilities actually have been the one for me. I am shocked by the number of folks that have reached out asking about Framingham and looking to do similar projects in their own states, their own service territories. And, it's great to not be doing it alone and have other people coming along with you, but exciting for me just to see it is not just a regional thing where we are. It is really across the state, across North America, across the world at this point. So that's exciting for me.
It's like the only thing everyone in the US agrees on at the moment. The ground beneath our feet.
Well, thank you all. I know we promised to let everyone go right at the top of the hour, but I really want to thank our three panelists. Y'all have been wonderful and very gracious with your time. Also, Danielle Sass-Burnett and Jessica Diaz at NARUG. And just thank you all for the positive message and bringing us a solution. I think as regulators, sometimes people bring you some problems and people argue about the problems. And it's so wonderful to see different solutions cropping up, different technologies, different things that we can all look to and learn more about, and kind of broaden the toolbox that we all have as we move forward to ensure that we can deliver on what all of our ratepayers need, but do so in a way that's affordable and equitable and really minds our impact on the infrastructure and the planet. And you are doing wonderful work, and so happy that you were able to join us today. Danielle's posted where you can find a recording, and she's posted many of the links from the slides, so please do use those. And with that, I hope everyone enjoys the rest of their day. Thank you so much for joining us for this great webinar.